Um, so very quickly, before we get into operations, monitoring, I try to make these slides very quick, but cover a few topics besides the general things that we do, have been doing for several years. With, mostly just want to give a quick update of some of the things that we did since last GEC. So we're continuing to sort of improve the UI improvements for facilitating emergency stop and LLR requests. We were able to do basically created an ability to look up project owner data from the clearinghouse and slice authorities. Not there, and I'll talk a little more about it. Just a few sort of slides on what that looks like. We can search by IP address, by MAC address, and find resources that may be affected or we're specifically looking for, whether it be an emergency stop or an LLR request, potential LLR request, I should say. The project owner search support is in the GMOC DB now. Of course, if you see, it's empty. So we need the clearinghouse and the slice authorities to begin sending us data. I'm sure this will be related, also tied in with the operational monitoring, and as that gets ramped up. But it is, it is extremely important, in a sense that, and once I talk about a little more about the LLR exercise, it will make a little more sense. But we do want to be able to, find the besides just whoever is associated with a particular slice, to be able to find their associated project as well for a timely response, or to be able to go to somebody that can help us take down the resource, whatever. So just, we're continuing to bring up the regionals that are coming up. We are currently supporting 9 regionals and growing. Those some new ones reporting to GMOC. The relational data, 21 is to GENI racks and 8 ExoGENI racks. Several that are not on this list but are in the works. These are all that have been accepted by GMOC and are sending relational data to the DB. So this is, kind of the overview, and I'm sure it's hard to see. Hopefully, in the document online, you'll be able to zoom in and see it a little bit better. But this gives a general process that we can follow in cases of an LLR request or legal, law enforcement, and regulatory requests that may potentially come in. GENI may be contacted by lawyers or law enforcement or regulatory agencies with requests to, regarding, behavior or a particular host that or an aggregate in GENI. There may be various scenarios such as DCMA takedown or taking down copyrighted material, contraband, downloads, cease systems, FBI coming in and wanting to take an entire rack, or, hopefully not, but, the process will certainly, hopefully, help them not take an entire rack, but, if we do plan for it, they can take a note, or they can take they can simply go to the particular slice owner or the project owner and deal with those requests, a little more targeted basis. But so, this, we recently did a second exercise. This one, first one we did prior to GEC19 was more of a tabletop exercise. This one was a little more interesting in terms of actually working with a third party or with one of the ExoGENI racks. Overall, our process seems to work pretty well. We were able to run through a scenario and from end to end and from beginning to end, and without too much trouble. Some of the participants we had GMOC GPO, Steve Schwab, who's the LLR representative, and I don't think I see him here today, but and Jonathan from Utah helped us on the ExoGENI side. Obviously we still need improvement, and as far as tools and data, some of the slides I showed you earlier, we're able to find sort of a general place where we can forward or find individual data from a subnet mask, but not particularly from within an IP address within a slice. So we can at least look up where this resource is, and it will give us a general direction of this is on a Utah rack, or this is on another resource that's that we have contact information for, and we can contact them for more detailed information for them to be able to find the offended resource looking for. So as operational monitoring ramps up, hopefully that information will be available, and that we can have a single place where we can go and find this information. And we need a historical data that to be able to search for timestamp as well as by IP, because obviously things are dynamic, things change very quickly from, and so to be able to go back in a historic fashion to find that was going to be important. You could receive a letter 3 months or 4 months after an event happened that people may be looking for, that we'd be able to point to the specific resource. So ExoGENI had a very straightforward way of dealing with, sort of taking down a resource or isolating a resource. They have 3 panic button levels that Jonathan I pointed out to. So level 1, they basically it reboots a host into NSF or admin state. Level 2, they actually power down the node and create firewall rules to completely isolate, and level 3 just completely removing a node. So what are the next steps? We try to better our process, better test these with various scenarios. I think doing a test with a multi-site involvement is going to be important. In this case with Utah, they're both a GENI aggregate operator, but they're also a slice authority. So doing something with an end site like University of Kentucky or Illinois, or someone that doesn't own their own slice authority as per the GENI does, or being able to test with them and see how how much back and forth we need to do, or if we need to contact a particular slice authority on their behalf. It's going to be interesting. So we hopefully after this GEC we'll do a test with ExoGENI and see how this process works with them. Some of the one of the ideas is probably I think is going to be important to be able to have a either a chat room or a conference call that's an ad hoc basis, though people can join and begin to work on when we receive one of these requests. And I think a lot of that is there, but making sure that whoever the LR representative is and the aggregate operators sort of are able to get on not only GMOC DB but also into these chat rooms or that are dedicated for this on a regular basis. So we don't want to reinvent the wheel, or but still have provide some opportunity for that. So of course with the SDN Exchanges, that's kind of opens up a brand new question. How do you deal with requests that for resources that are outside of U.S. laws and regulatory commissions and whatnot, or rules. And so dealing with that is going to be interesting, and having a way to at least point people towards Internet 2 even, or ESNet or other entities. And again, I think some operational monitoring, operational information for getting that information from the SDN Exchanges is going to be important there. And something that Steve brought up, and I think this is, and well, actually Heidi, how do we identify, recruit, and train on a regular basis to make sure there is an additional LLR representative or representatives, and that they are not out of tune with how things are going, and making sure that we're continuing to work that is maybe a challenge as well. Just a few statistics. We recently started doing this, but this sort of helps us to track the trends and identify some peak times and things like that. So I think you sort of see how things are probably related to pre-GEC or post-GEC activity, certainly end-of-year events, with tracking phone calls, tickets, emails. I'm going to skip through most of the GMOC DB stats. A little bit interesting. Some of this, of course, is just a snapshot, especially with the slices. The contacts are growing at a crazy rate, so that certainly is showing as GENI grows. A lot of these statistics will continue to grow as well. And I'm not going to spend a whole lot of time on this slide. I just want this to sort of be out there for people to think about for operational challenges or needs as we go forward. That all of these things are not easily achievable, but we are working on a lot of these areas, and certainly hoping that this will become an operational network, and we're able to do things as a real network and do things in a timely fashion. So questions, comments, anything, you know how to contact us, the operational calendars. And I'm going to, unless there's any questions, I'm going to let the operation monitoring folks. Okay.
Can you hear me? Okay. All right. Good. All right. I've actually never worn one of these things before. Great. So my name is Ryan Irwin. I'm with the GPO, one of the new members of the GPO. And I was brought on board in the infrastructure team to work on operational monitoring and kind of revamp how it's done and rethink about how we want to scale and distribute different sources of information when we have new racks come online. We have different use cases for operational data and monitoring and visualization, and we really need to have, we have all this data in different places and different formats for accessing it. We need a common way for people visualizing that data or getting reports on that data to have access to it. So the approach we came up with in help with the community and the monitoring list basically distributes data sources and collection points. This is in contrast to the previous requirement of pushing data to GMOC. And the requirement is that if you have an aggregate, and you have data about it, of course, then you expose an interface to get to that data. And we created a simple interface using standard web tools to do this. So this enables a diverse set of operator-preferred tools, so you don't have to use SNMP, you don't have to use Nagios. You can use whatever you want within the monitoring framework that we provide. And of course, this is extensible to new aggregates coming online in terms of a simple software package, and it's simple to understand, and when we transition post-GPO, it'll be easier for operators to monitor their own rack in addition to having some central monitoring services as well. So it's a kind of a flexible architecture. All right, so the basic overview of the new architecture is, so the things on the bottom and the things on the top are very much well understood, and there's a lot of tools for that already. What we've been working on is a protocol for getting data from a local source, or what we've called a local database, where collections of time series and relational data are near an aggregate, to kind of an area for collection, and what we've called collectors. And so so right now we have a limited deployment, and I'll get into some of that in detail in a minute, but there'll be multiple local data stores and multiple collectors. And the point is that your local data store and your aggregate will have data that will be accessible to all collectors for different purposes. And the collectors will pull for the data they're interested in, and in terms of their monitoring jurisdiction, in terms of like geography, or in terms of like they're interested in memory utilization data instead of reporting on what slices are being used, for instance. So it's a flexible architecture so you can get you can stand up your own collector to collect what information you want based on whatever aggregates you want to collect information from. And how this might look inside of the GENI architecture is that it's basically what I was just saying, that the different aggregates have a local data store that expose this API for different monitoring groups to collect information from. And so I've drawn just 3 examples on the top where some monitoring group may be collecting, say in the middle, say like University of Kentucky may be collecting monitoring information to do alerting, visualization, and reporting, whereas some local rack team or some rack team that stand up their own rack, they only want to monitor their rack, so they may just collect it, where the Kentucky guys may connect to all these different local data stores to get their information. So to connect between the collector and the local data store, we've used some simple tools. They're common web friendly tools like JSON and REST. There are 2 types of REST queries. So the collector will make periodic REST queries, and the local data stores will respond in JSON format. The first type of REST query is an information-based query, and so this type of query just exposes the type of information that you will find at this local data store or at this aggregate. So this will be things like node IDs, interface IDs, VLANs. Basically, it's pointers to object information at the local data store. And the way the collector will go about collecting this information is that it basically web crawls the local data store. So I'll show you in a minute exactly how that looks. But okay, so then once it gets the information about what is at that local data store, it will more frequently make data queries. And the data query format is a little bit different. It's still a REST call. You provide that the collector will provide a set of object IDs to query. It'll provide the different statistics it wants to collect information about and a timestamp about that. So a little bit more details about the information REST queries. Like I was saying, the info REST calls, you start by querying information about the aggregate with this thing that we've termed the head info aggregate query, and it returns things like the nodes at the aggregate, the slivers, and other resources like links, which we're still trying to work out exactly the details on monitoring VLANs. So once you get information about the aggregate info query, you get links basically to something that looks like this bottom link. So this would be, when this returned, it would return you several hrefs to another link to crawl and get more information about the aggregate. The important point to note here is that the object IDs that are returned and used to make these queries are used in the next data queries. So the data queries are also REST queries, and you basically pass a Python dictionary style argument to as part of your query in this here. So the filters, and I call it the filters dictionary. So the filters contain a list of event types like CPU utilization, RxBPS, timestamp window. You specify the well, exactly what it sounds like, and the object IDs in a list, a node or interface, and then depending on the number of object IDs you provide and the number of event types, you'll get an array of data responses. So it kind of is a bulk transaction. You don't have to request every node, every statistic. It simplifies the number of calls to make for monitoring. So the important thing to note here is what is it that we've suggested to be a requirement. We've suggested that the local, the rack teams and the aggregates provide expose this interface that I just covered these last 3 slides, and so they can implement to this standard. What we don't require is a set of tools. We want you to have a computer and some databases, or some kind of data store, but we don't require you to implement some sort of, I don't know, obscure protocol. However, we do provide a reference implementation which we're willing to support, and it supports both Postgres and MySQL, and we've implemented a Python program which transforms REST queries to SQL and JSON responses. We implemented the crawling of the local database info and some fetching data. So we've basically implemented most of both sides of the local data store and collector implementation, and the code is provided here. And these slides are online on the section page. So the deployment status is growing quite rapidly the last 2 weeks, coming up to the GEC. We now have both rack teams. We have limited deployment in Utah, ExoGENI. We have some deployment in the WVNet, RENC, network aggregates, AL2S, Internet 2 at the mesoscale, and ION and MAX, accessing regional access to ION. Also, I don't see Cody, but last night Cody Baumgartner of UK had a really nice demo of he implemented his own collector for exposing the data he collected through this API. Actually, I have a slide on that in a second. And we are alerting on multiple resources in Nagios using this framework. So just going to give an example of what this looks like and how it's actually easy to debug because you can just plug it in your web browser and look at it. So here's an example of an info call to an ExoGENI node, and it's this particular node, WVN W7. It returns, a JSON-style dictionary with information about the ports. So if you want to monitor these different ports, you will gather these object IDs through this info query. And I truncated this. There's lots of ports on this particular node. Similarly, there's AL2S, uses the AJ Ragusa, implemented using using some protocol to access his data. We're actually not sure, but using some protocol to access his internal data store, because they're already collecting this information. They just need to transform it into the local data store API. This is a data query. So again, it looks just like, as I was saying, it's a JSON array with, this is the first event type, RX BPS, and this is TX BPS. So it's an array of two different event type times object IDs. So this is an example of Nagios. Is not something groundbreaking. Obviously, most of you have probably seen Nagios before. We implemented just during some testing. We tested an iPerf test of a resource that not on GENI, so we didn't host any of the resources on GENI. We hosted our own resources and monitored that, and saw that iPerf caused an alert to go off. What's exciting about this, though, is this same architecture provided a new way for, so using the same architecture, we get a totally different type of information interface. And so we have alerting APIs for Nagios, and we have visualization API and reporting API yet to be developed, all using this way to get information in a common format from many different sources and many different developers and teams. So many thanks to all those who helped us along the way so far. Again, this is something that didn't even exist last GEC, so we're really excited about all the progress we've made. So here, so we're having tomorrow at the coding sprint. We'll be there, and we are interested in hearing some of your feedback and questions and comments for some of the design points going forward. And here's some of the resources. You can join the monitoring list, and are often on IRC. So actually, we'll point out that there are some, so you can get access to our code here, and our wiki page that has more documentation about this is listed here as well. And this use cases page has more details about the types of things we'd like to do in the future that would be supported by this architecture. So that's all I have. Any questions, or probably not? So if you have any questions, come tomorrow to the coding sprint at 1:30.